Chapter 15: An Element of Madness. Robert Lowell may have been known as a mad artist, but what about mad scientists? The mad scientists of the periodic table were usually caught up in a special kind of madness known as pathological science. Pathological science is a strange kind of madness whereby normally reasonable and logical scientists choose some highly unlikely phenomenon that, for whatever reason, appeals to them, and then use all their scientific knowledge and skill to try to prove it's true. What's really fascinating about that madness is how it can exist side by side in the same mind with brilliance. Spiritualism and Selenium. Unlike almost every other scientist in this book, William Crookes, born in London in 1832, never worked at a university. The oldest of 16 children, he later fathered 10 of his own, and he supported his enormous family by writing a popular book on diamonds and editing a scientific journal called Chemical News. Nevertheless, Crookes did enough world-class science on elements such as selenium and thallium to get elected to England's premier scientific club, the Royal Society, in 1863 at just 31 years of age. A decade later, he was almost kicked out. His downfall began in 1867 when his brother Philip died at sea. William and the other Crookeses nearly went mad with grief. For comfort, William turned to the newly popular movement called spiritualism. Part of the spiritualist movement was the idea that you could communicate with the dead during gatherings called seances, and William was keen to get in touch with his recently deceased brother. This wacky behavior put Crookes in the minority among his fellow scientists in the Royal Society. Knowing this, Crookes kept his beliefs secret, and in 1870, when he announced that he had drawn up a scientific study of spiritualism, most fellows of the Royal Society were delighted. They assumed he would demolish the whole idea of spiritualism in his journal. Things did not turn out so neatly. In 1874, Crookes published a paper titled Notes of an Inquiry into the Phenomena Called Spiritual in a journal he owned called the Quarterly Journal of Science. Instead of attacking all the spiritualist mischief, levitation, phantoms, percussive sounds, luminous appearances, the rising of tables and chairs off the ground, he concluded that there were some real supernatural forces. Coming from Crookes, this support amazed everyone in England, including the spiritualists. Crookes' fellows in the Royal Society were equally surprised, but rather more upset. They argued that Crookes had been blinded by tricks and conned by charismatic mediums. They also tore into the dodgy science that he'd given in his report. A few scientists cannot forgive him to this day, and they even point to his work on the elements as proof that he went crazy. Why is that? Well, Crookes had previously studied selenium. Though selenium is an essential trace element in all animals, it is toxic in large doses. Cattle ranchers know this well. If not watched carefully, their cattle may find a prairie plant of the pea family known as loco weed, and some varieties of which soak up selenium from the soil. Cattle that munch on loco weed begin to stagger and stumble and develop fevers, sores, and anorexia, a set of symptoms known as the blind staggers. The surest sign that selenium actually makes cattle go mad is that they grow addicted to loco weed despite its awful side effects, and they stop eating anything else. Overall, it's fitting that selenium comes from selene, Greek for moon, which has links through luna, Latin for moon, to lunatic and lunacy. Given that, it may make sense to blame Crookes' delusions on selenium, but some inconvenient facts get in the way. Selenium often attacks within a week. Crookes got goofy in early middle age, long after he'd stopped working with selenium. Plus, many biochemists now think that other chemicals in loco weed contribute just as much to the craziness and intoxication of the cattle. Finally, in a clinching clue that selenium did not influence Crookes, his beard never fell out, a classic symptom of selenium poisoning. A full beard also suggests that Crookes was not driven mad by another poisonous element on the periodic table, the poisoner's poison, thallium. Crookes discovered thallium at age 26, a finding that all but ensured his election to the Royal Society, and continued to play with it in his lab for a decade, but he apparently never inhaled enough even to lose his whiskers. Crookes actually gave up his spiritualist ideas after 1874, rededicating himself to science, and major discoveries lay ahead. He was the first to suggest the existence of isotopes, atoms of the same element with different number of neutrons. He built vital new scientific equipment and confirmed the presence of helium in rocks, its first detection on Earth. In 1897, the newly knighted Sir William dived into radioactivity, even discovering, though without realizing it, element 91, protactinium, in 1900. As such, the best explanation for Crookes getting mixed up in spiritualism was that, ruined by grief for his brother, he was taken in by pathological science, not that selenium or thallium drove him mad. Shark teeth. A pathological science takes advantage of the researcher's caution. Basically, its believers use ambiguity about evidence as evidence, claiming that because scientists do not know everything, there is room for their pet theory, too. That's exactly what happened with manganese, element 25, and the Megalodon. This story starts in 1873 when the research vessel HMS Challenger set out from England to explore the Pacific Ocean. In a wonderfully low-tech setup, the crew dropped overboard huge buckets tied to ropes 3 miles long and dredged the ocean floor. In addition to fantastical fish and other critters, they hauled up dozens upon dozens of spherical rocks shaped like fossilized potatoes and solid mineralized ice cream cones. These hunks, mostly manganese, appeared all over the seabed in every part of the ocean, meaning there had to be untold billions of them scattered around the world. That was the first surprise. The second happened when the crew cracked open the cones. The manganese had formed around giant shark teeth. The biggest, most freakish shark teeth today run about 2.5 inches max. The manganese-covered teeth stretched 5 inches or more, mouth talons capable of shattering bone like an axe. Using the same basic techniques as with dinosaur fossils, paleontologists determined, just from the teeth, that this ancient jaws, dubbed the Megalodon, grew to approximately 50 feet, weighed approximately 50 tons, and could swim approximately 50 miles per hour. It could probably close its mouth of 250 teeth with a megaton force, and it fed mostly on primitive whales in shallow tropical waters. It probably died out when its prey migrated permanently to colder, deeper waters, an environment that didn't suit its high metabolism and ravenous appetite. All fine science so far. The pathology started with the manganese. Shark teeth litter the ocean floor because they're about the hardest biological substance known, the only part of shark carcasses that survive the crush of the deep ocean. Most sharks have cartilage for skeletons. It's not clear why manganese, of all the dissolved metals in the ocean, covers shark teeth, but scientists know roughly how quickly it accumulates, between 1/2 and 1.5 millimeters per millennium. From that rate, they have determined that the vast majority of recovered teeth date back at least 1.5 million years, meaning that megalodons probably died out around then. But, and here was the breach into which some people rushed, some megalodon teeth had mysteriously thin manganese plaque, about 11,000 years worth. Evolutionarily, that's an awfully short time. And really, what's to say scientists won't soon find one from 10,000 years ago, or 8,000 years ago, or later? You can see where this thinking leads. In the 1960s, a few enthusiasts with Jurassic Park imaginations grew convinced that rogue megalodons still lurk in the oceans. "Megalodon lives!" they cried. And like rumors about UFOs and Area 51, the legend has never quite died. The most common tale is that megalodons have evolved to become deep-sea divers and now spend their days fighting krakens in the black depths. Like Crookes' phantoms, megalodons are supposed to be elusive, an explanation that gives people a convenient escape when pressed on why the giant sharks are so scarce nowadays. There's probably not a person alive who, deep down, doesn't hope that megalodons still haunt the seas. Unfortunately, the idea crumbles under scrutiny. Among other things, the teeth with thin layers of manganese were almost certainly torn up from old bedrock beneath the ocean floor, where they accumulated no manganese and exposed to water only recently. They're probably much older than 11,000 years, and although there have been eyewitness accounts of the beasts, they're all from sailors, notorious storytellers, and the megalodons in their stories vary maniacally in size and shape. One all-white Moby Dick shark stretched up to 300 feet long. Funny, though, no one thought to snap a picture. Overall, such stories, as with Crookes' testimony about supernatural beings, depend on subjective interpretations, and without objective evidence, it's not plausible to conclude that megalodons, even a few of them, slip through evolution's snares. But what really makes the ongoing hunt for megalodons pathological is that doubt from the establishment only deepens people's convictions. Instead of refuting the manganese findings, they counterattack with heroic tales of rebels, rogues who proved Squareville scientists wrong in the past. They invariably bring up the coelacanth, a primitive deep-sea fish once thought to have gone extinct 80 million years ago, until it turned up at a fish market in South Africa in 1938. According to this logic, because scientists were wrong about the coelacanth, they might be wrong about the megalodon too. And might is all the megalodon lovers need. For their theories about its survival aren't based on a preponderance of evidence, but on an emotional attachment, the hope, the need for something fantastic to be true. Rontgen's rays. Not every scientist with a touch of madness ends up drowning in pathological science, of course. Some, like Crookes, escape and go on to do great work. And then there are the rare cases where what seems like pathological science at the beginning actually turns out to be real science in the end. William Rontgen tried very hard to prove himself wrong while experimenting with invisible rays, but he couldn't. In November 1895, Rontgen was playing around in his laboratory in central Germany with a Crookes tube, an important new tool for studying subatomic phenomena. Named after its inventor, you-know-who, the Crookes tube was a vacuum in a glass bulb with two metal plates inside at either end. Running a current between the plates caused a beam to leap across the vacuum. A crackle of light, something from a special effects lab. Scientists now know it's a beam of electrons, but in 1895, Rontgen and others were trying to figure that out. A colleague of Rontgen had found that when he made a Crookes tube with a small aluminum foil window in the glass, the beam would tunnel through the foil out into the air. It died pretty quickly. Air was like poison to the beam, but it could light up a green phosphorescent screen a few inches away. Rontgen repeated the experiment in 1895, but with some alterations. Instead of leaving his Crookes tube naked, he covered it with black paper so that the beam would escape only through the foil window. And instead of the phosphorescent chemicals his colleagues had used, he painted his plates with a barium compound. Accounts of what happened next vary, but basically every time he turned the current on, a barium plate would glow. But the crazy thing was that the plate was not located near the Crookes tube. It was clear across the laboratory. Rontgen confirmed that no light was escaping from the blackened Crookes tube. He'd been sitting in a dark lab, so that sunshine couldn't have caused the glow either. But he also knew the Crookes beams couldn't survive long enough in air to jump over the barium plate sitting far away from the tube. He later admitted he thought he was imagining things. The tube was obviously the cause, but he knew of nothing that could travel through the black paper. It was a mystery. So Rontgen continued to experiment. He propped up a barium-coated screen and put the nearest objects at hand, like a book, near the tube to block the beam. To his amazement, an outline of a key he used as a bookmark appeared on the screen. He could somehow see through things. The truly black magic moment came when he held up another object and saw the bones of his own hand. At this point, Rontgen thought he'd gone stark raving mad. But far from it, he'd actually discovered X-rays. Interestingly, instead of leaping to the convenient conclusion that he'd discovered something completely new, Rontgen assumed he'd made a mistake somewhere. Embarrassed and determined to prove himself wrong, he locked himself in his lab for 7 weeks. He dismissed his assistants and took his meals grudgingly, gulping down food and grunting more than talking to his family. Unlike Crookes, Rontgen tried to fit his findings in with known physics. He didn't want to be a revolutionary or claim that he had discovered something new. He even tried hard to disprove himself. But the Crookes tube lit up the barium plates every time, despite his doubts. At last, slightly more confident that he was seeing something real, he brought his wife into the lab one afternoon and exposed her hand to the X-rays. When she saw her bones, she freaked out, thinking it was a premonition of her death. She refused to go back into his haunted lab after that, but her reaction brought huge relief to Rontgen. It proved that he hadn't imagined it at all. At that point, Rontgen announced his Rontgen rays. Naturally, people doubted him just as they doubted Crookes, but Rontgen had been patient and modest, and every time someone objected, he countered by saying he'd already investigated that possibility until his colleagues had no more objections. And here is the uplifting side to the normally severe tales of pathological science. Scientists can be cruel to new ideas. One can imagine them asking, "What sort of mystery beams can fly invisibly through black paper, Wilhelm, and light up the bones in your body?" Nonsense! But when he fought back with solid proof, with repeatable experiments, most threw out their old ideas and embraced his. Though an ordinary professor his whole life, Rontgen became every scientist's hero. In 1901, he won the first Nobel Prize in Physics. 2 decades later, physicist Henry Moseley used his electron gun and some X-ray detectors to revolutionize the study of the periodic table. Even better, in 2004, element 111 was named Rontgenium in Wilhelm's honor.